Hey guys, this is Miss Adams again. We're looking at part 2 of how to graph linear inequalities. So first off, the solution to a linear inequality on a graph is any point that falls in the shaded region of that linear inequality graph. So we're going to have a few different types of lines. We're going to have dashed lines and solid lines. Our dashed lines are going to be for our less than or greater than inequalities, and our solid lines are going to be for our less than or equal to or greater than or equal to linear inequalities. If we're looking at something that is less than or equal to, we're going to shade our graph below our linear inequality. And if we're looking at a graph that is greater than or equal to, we're going to shade above that line. So I'll show you guys some examples here. So if I were to just look, so for all of these, I'm going to look at when y is less than x, when y is greater than x, when y is less than or equal to x, and y is greater than or equal to x. So I'm just going to draw a rough coordinate plane here. And y is less than x. So I'm going to draw a dashed line. And I'm going to shade the region below this dashed line. And that'll be y is less than x. If I'm looking at y is greater than x, still going to be a dashed line, but since it's greater than it, the region that could be your solution is going to be above that line. Now, when I'm looking at y is less than or equal to x, my solution can be on the line, so a point on the line can be a solution. So therefore, I'm going to have a solid line, but I'm going to shade below because it's everything less than or equal to that inequality. And then when I have y is greater than or equal to x, that's going to be everything above my line. I'm going to have a solid line, so it's everything that either equals that line or is above that line. So let's talk about that in words. So if the line is solid, a point on the line is a solution. But if you have a dashed line, so that's when you have less than or greater than, a point on the line is not a solution. So remember, solid is going to be less than equal to or greater than or equal to. Dashed is less than or greater than. We're going to graph linear inequalities just like we graph linear equations. You're going to graph it using the y-intercept and the slope. Then we're going to decide which way to shade by selecting a point anywhere on the plane. The origin is usually the easiest. And then we're going to test to see if it is a solution to the inequality. You're going to shade in the direction that makes that inequality true. So let's do some practice here. Graph each linear inequality on the graph given. Then use your graph to determine if each point is part of the solution. So I've given you y is less than or equal to negative 3x plus 1. So we would graph this just like we would a linear equation. So we've got to start off with our y-intercept, which is 1. So I'm starting off at 1 on our y-axis. My slope is negative 3, which is the same thing as saying negative 3 over 1. So I'm going to go down 3, to the right 1. I also could go up 3 and to the left 1. Now we want to look at our inequality symbol. So in this case, I've got less than or equal to. That means I'm going to have a solid line. That goes through my points. And I'm going to shade below this line, which means my shaded region is going to be all of my lower y values. So let's look at the point 3, 1. So this is the first point given to us is at point A. So I'm going to be at 3 on the x-axis, 1 on the y-axis. This is not in our shaded region, so this is not a solution to this inequality. Let's look at the next point given. We're given the point negative 2, negative 2. Negative 2 is in our shaded region, so yes, this is a solution for our linear inequality. I've given you a you try problem. I'm going to work it out silently while I give you guys a second to work it out yourselves. Does your graph kind of look like mine? I've got y is greater than 3 half x minus 2. So I started at negative 2 on the y-intercept. I did my slope where I went up 3 to the right 2. I made my line dash because it's greater than, and I shaded above also because it is greater than. So let's look at my points. I've got the point 2, 1. This lies on my line, but because it's a dashed line, this is not a solution. And then we've got the point negative 4, 1. This does lie in my region, so it is a solution. Alright guys, stay tuned for part 3.